Welcome to the Global Reader. Today, we journey back to the dramatic intellectual battlegrounds of the 17th century, where a single man stood at the crucible of history, Galileo Galilei. Born in Pisa in 1564, Galileo was more than an astronomer. He was the precursor of modern science, challenging the entrenched doctrine of his age with empirical evidence and an unwavering commitment to inquiry. His life story is an epochal tale of the conflict between observation and dogma, between a world seen through a telescope and a world defined by ancient philosophy. Our focus for English learning is linking words, specifically those that add information or connect related ideas in a sophisticated manner. We will master terms like furthermore, in addition, moreover, and besides. You will learn how Galileo built his scientific arguments, layering evidence upon evidence. In addition to understanding his scientific discoveries, you will master the language necessary to build your own complex, cohesive arguments. Chapter 1. The Formative Years and the Empirical Mind. Galileo Galilei was born into a modestly affluent family. His father, a musician, recognized his son's powerful intellect and ensured he received a good education. Initially, Galileo studied medicine at the University of Pisa, but his true passion lay in mathematics and physics. He quickly grew disillusioned with the prevailing pedagogy of the university, which relied almost entirely on the authority of ancient texts, primarily those of Aristotle. Aristotle's physics, a complex and entrenched doctrine, had dominated European intellectual life for nearly 2 millennia. This philosophy, largely integrated with religious teachings, held that heavy objects fall faster than lighter objects. Galileo, however, believed that direct observation and mathematical analysis were the only true paths to knowledge. In addition to his academic studies, Galileo spent his early career as a professor of mathematics, first at Pisa and subsequently at the University of Padua. He quickly established a reputation as a brilliant, if sometimes contentious, thinker. Furthermore, he became an inventor, designing and improving instruments like the hydrostatic balancing thermometer compass. His mind was constantly searching for practical, verifiable truths. He was a dedicated proponent of the scientific method, emphasizing repeatable experiments over mere speculation. His core tenet was this: nature writes its laws in the language of mathematics, and only by using the tools of measurement and calculation could humanity truly read them. Moreover, he realized that challenging the established dogma would require irrefutable, empirical evidence. This dedication to truth would soon put him at odds with the most powerful institution in Europe. Chapter 2. The Telescope. A new epoch of observation. The year 1609 marked a watershed moment, not only for Galileo's life but for the history of science itself. Hearing of a simple optical device invented in Holland, the spyglass, Galileo immediately set about improving it. He meticulously ground his own lenses, constructing a far more powerful instrument, the astronomical telescope. He did not simply look through it. He turned it toward the heavens, initiating an epochal transformation in humanity's view of the cosmos. His astronomical observations quickly produced a cascade of evidence that directly undermined the geocentric model, the doctrine that placed the Earth at the center of the universe. In addition to simply seeing more stars than ever before, his initial discoveries were profound. The moon, the prevailing Aristotelian view, held that celestial bodies were perfect, smooth spheres. Galileo's telescope revealed that the moon was imperfect, marked by mountains, craters, and valleys, much like the Earth. Furthermore, this showed that the heavens were made of the same material as our world, not some perfect ethereal substance. The Medicean stars. He discovered 4 small celestial bodies orbiting Jupiter. Moreover, their movements clearly demonstrate that not everything revolved around the Earth. These discoveries, which he famously named the Medicean stars, now known as the Galilean moons, provided a powerful visual analogy for the heliocentric model, sunspots and Venus. Besides the moons of Jupiter, he observed sunspots, proving the sun was not immutable, and documented the phases of Venus, similar to the moon's phases. Consequently, the face of Venus provided compelling evidence that Venus orbited the sun, not Earth. The dissemination of these observations in his book, Sidereus Nuncius, Starry Messenger, created an immediate sensation. The empirical evidence was unassailable. However, in addition to generating scientific excitement, These findings ignited the bitter, turbulent conflict with the established dogma. Chapter 3, The Dogma of Heresy and the Trial. The heliocentric theory, originally proposed by Nicolaus Copernicus, was viewed as a direct subversion of the traditional biblical and Aristotelian worldview. The Earth was believed to be the literal center of creation. Consequently, suggesting otherwise was considered heresy, a danger challenge to religious and social order. Although Galileo had many supporters among the educated elite, the ecclesiastical authorities of the Inquisition were alarmed. In 1616, the Church declared the Copernican doctrine to be formally heretical, banning Copernicus's book. Galileo was admonished to abandon the theory and henceforth to hold it only as a mathematical hypothesis, not a physical truth. For a decade, Galileo maintained an uneasy silence on the controversial subject. However, the irresistible pull of truth and inquiry was too strong. In 1632, he published his masterpiece, Dialogue Concerning the Two Chief World Systems. This work, written in Italian rather than academic Latin to maximize dissemination, was ostensibly a discussion between three characters: an intelligent Copernican, a neutral observer, and a stubborn Aristotelian. The Aristotelian, named Simplicio, was portrayed as foolish and easily confused. Furthermore, the book was structured to make the Copernican argument irrefutable. In addition to presenting the accumulated empirical evidence, Galileo made no secret of his own convictions. This public advocacy was perceived as a direct act of defiance against the 1616 warning. The inevitable consequence was his trial by the Holy Office in 1633. Chapter 4, Recantation and the Enduring Legacy. The trial of Galileo was a pivotal moment. Aged and ailing, he was brought before the Inquisition and subjected to intense pressure. He was forced to choose between his life and his empirical truths. Besides the threat of torture, the implication was clear: only complete recantation would save him. On June 22, 1633, Galileo was compelled to kneel and read a prepared statement of abjuration. He solemnly renounced his belief in the motion of the earth and the stability of the sun. He publicly confessed his error and was sentenced to permanent house arrest. It is often recounted, though likely apocryphal, that upon rising from his knees, he muttered the famous phrase, "Eppur si muove," and yet it moves. In addition to his house arrest, his book was placed on the Index of Prohibited Books, where it remained for over 200 years. Moreover, the lesson of his trial served as a chilling warning to other scientists: empirical truth must yield to dogma. However, the silencing of the man did not silence his legacy. During his house arrest, Galileo continued his work, focusing on mechanics and the strength of materials. Furthermore, his final masterpiece, Discourses and Mathematical Demonstrations relating to two new sciences, was smuggled out of Italy and published in Holland, forming the foundational tenets of modern physics and kinematics. This final act of intellectual advocacy ensured that his empirical methods and unassailable observations would endure. The paradigm shift he initiated was irreversible. Conclusion: the triumph of inquiry. Galileo Galilei's life was a painful but triumphant testament to the power of inquiry. He taught the world the necessity of doubt and the primacy of direct observation. His struggle against dogma was a pivotal conflict that helped usher in the Age of Enlightenment. For English learners, this narrative has provided you with critical linking words. You have seen how words like furthermore, in addition, moreover, and besides are used to build sophisticated arguments, adding clarity and cohesion to your writing and speaking. By using the selinks, you can structure your ideas logically, much like Galileo structured his empirical evidence. Galileo proved that the truth, once observed, cannot ultimately be confined by dogma or decree.